Good morning, everybody. Mr. Moraine here. It's Friday, the 22nd of May. I hope everybody is well and somehow adjusting to being home and online learning. This is another example of a newer kind of SAT problem. It's been around for about 4 or 5 years now. And the category is problem solving, data analysis, and in this case, mathematical modeling. Read the question to yourself, and pause the screen and just read it. All right. As with any word problem of this length, the greatest issue for students is somehow getting through the problem and not forgetting what they read and what's important, what's not important. That's where highlighting comes in. And this is perhaps the most important thing you can do. So in our problem, I would say highlighting the phrases in the problem that are important. You've got the formula, of course, but you're not going to miss that. X here. Number of years required. Well, I could start underlining everything now, right? You never know when to stop, but just highlight, because as you're highlighting, you are understanding the problem better or realizing which phrases are not clear to you. But here's a very important piece of information. S and D are the sons and dads' current ages, and the key word here is current. Respectively means in that order. So S is for son, D is for dad. And then they give the current ages using the adverb currently. And now the question part. How old will the dad be? Now that's probably the most important part of the question. And that's when you want to highlight that even more, what they're asking for. And I covered it up here. It says when the son's age is 3/4 of his age, the dad's age. We have to come back and make sense out of 3/4. The restrictions, well, normally the variables in a math problem will have restrictions. If there are no restrictions on X or D or S or N, that would mean they could be any real number in mathematics generally or on the SAT. Now, I left off the restrictions here because there would be several of them, and that's a problem in and of itself. So you will just have to use common sense restrictions. For example, you certainly don't want N to be greater than 100, right? In fact, I'm not sure you would want N to be equal to 100%. We know that the son's age will never equal the dad's age. And mathematically, if N were 100, then this expression here would be 0, and you cannot divide by 0. So we know that N is less than 100. And we know it's positive. So for the moment, I'm just going to mention that 0 less than N less than 100. And let's leave it at that. That could have been the basic restriction given in the problem. Well, we did the highlighting already, so now we substitute. I mean, that's something we don't have to explain to students. They see a formula, they see numbers, they plug in. But we have to be very careful what we are substituting into which variables. So X equals. Now, sometimes it's helpful to take the information in the problem and make a little data table before we substitute. So for example, here, we could say the son and dad are currently 5 and 25. So that would mean the dad's current age is 25. The son's current age is 25. Sorry about that, 5. And now we come to our first critical point in solving, and that is what to replace N by. Well, we want the son's age to be, in the future, 3/4 of his dad's age. But that is not a percent. So we have to convert that to 75%. But remember, N is the numerical value of the percent, or the number attached to the percent, so N is 75. without the percent sign, right? Because it says that right here, n%. So that was tricky. We have to be, that there are only two impediments or obstacles in this problem, and that was one of them. Now we're ready to substitute, so we have x equals n times d, and I like parentheses, n, 75, times d, 25, minus 100s, so 100 times 5, all over 100 minus n. Okay, so we're going to go to the next page. And let's look at that now. So we'll repeat that last equation. N was 75. Dad's age, remember that's the current age, minus 100 times the son's current age, all over 100 minus the value of n, which was 75. Are we okay? Now remember, this could be on a non-calculator part of the test. One section, the non-calculator section, for example, has 5 of these grid-in type questions, no choices. And so you want to use good mathematical skills to compute, but hey, you want to get the answer correct. So if you have to multiply it out, divide it out, be careful with your subtraction, don't do it mentally, that's fine. But I'm going to leave it and not multiply it out. 7525 minus 500. Now, you know what? We're going to leave it as 100 times 5. All right. And the denominator is 25. Now, here we're going to use basic properties of arithmetic, which are so important. You need that solid foundation so that as you get into more advanced mathematics, you could save time. Since the numerator has subtraction, we can distribute the division. Remember, the distributive property applies to both multiplication and division, since dividing by 25 is the same as multiplying by the reciprocal 1 over 25. So we're going to distribute this. And the first thing we're going to do is look at 75 times 25 over 25. And then distributing, we're going to do the next division, 100 times 5 over 25. And now we're going to reduce these fractions. So 25 divided by 25 is 1, so that's 75. 25 goes into 100 4 times, and 4 times 5 is 20. So we're done. The answer is 55. But we're not. We think we're done, but remember what I said earlier. Answer the question. The question is asking for how old will the dad be, right? Remember this? So we're not done. We want the dad's future age in how many years? 55 years. So the dad's current age is 25, and in 55 years, he will be 80, and that's your answer. And when you grid in the 80, remember what they tell you. But students rarely read these directions, so I'm going to read it for you, or I'll highlight it for you. We could put the 80 here. We could put the 80 there. The software does not fill in zeros and make it 8,000, so that's perfectly acceptable. But since this can be confusing, I strongly recommend working from the right for a whole number. If it's a decimal, that's a different story. Then I would work from the left. But this is fine, 80. I hope this helped, and if you, obviously you need to go back, rewind. The famous one about lather, rinse, repeat. In this case, go back, pause, try to figure it out for yourself, see what you remember from the solution, then advance, scroll through it, stop, see if you can finish it by yourself, and you will have developed more proficiency when you can do the entire problem by yourself. But the key to becoming proficient in mathematics is to be able to do 5 to 10 others like this with variations. That's when you know you have command of the problem. You're in control. And there are so many of these types of questions on practice SATs that you can find. You can go off on your own now. Hey, if you enjoyed this, if you think it's helpful, other than being long-winded, of course, I would ask you to like it, and most importantly, subscribe to this channel, because that's what will tell me that it's worth developing these, going on with them. And please comment with questions, constructive criticisms, and I will always respond to your comments. Thank you.